Good evening, everyone. Our object of study is a volume of irregular objects, which is based on primary school mathematics, 5th grade, 2nd semester, People's Education Press. Our group members are 端木惠利、顾夏雨、胡剑桥, and 邱思佳. And our presentation will divide into the following 4 parts. We chose constructivism as our foundational or educational theory and implemented it using the 5E model, aiding IPM to assist. Next, let's have a quick review on constructivism. First, actively. During the learning process, learners actively construct knowledge rather than passively receiving it. Second, social, which means we have cooperation and communication with others. Third, conform. We need to integrate new knowledge with prior knowledge to form new structure during the learning process. Fourth, individual. Learners' prior knowledges and experience have a significant impact on the learning process. So our teachers need to pay attention to learners' individual differences and provide personalized instructional support. Beyond that, the relationship between constructivism and mathematics can be summarized in 3 points. Interaction, understanding, and the individual. In mathematics education, constructivism means that students should understand mathematical concepts through manipulating physics or physical objects, problem solving, and collaborative activities. And for the differences between the students, we may adopt diversified assessment methods. Then the method of implementation, 5E model. The 5E education model is a constructivist instruction framework designed to promote students' understanding and application of science concepts through engagement, exploration, and reflection. The model was developed by the Biology Curriculum Study Societies in the early 1990s and is widely used in K-12 education. The 5E model consists of 5 sequential phases, including exploring, explaining, extending, and evaluating. As I said before, we also use IPM, the information processing model, which is originates from cognitive psychology and aims to analyze the information processing mechanism of the human brain. With its development, the model has been widely used in the field of education and has become a key tool for instructional design and comprehension. The IPM simplifies this learning process as a process of receiving, processing, storing, and retrieving information, and emphasize instructional design should help students process information effectively. The core of IPM is centering in memory, short-term memory, long-term memory, cognitive processing, and metacognition. Besides, by understanding students' perceptual and attentional process, teachers can design more effective instructional strategies, such as using objects or images to help students better understand and remember math concepts and formulas. By understanding students' memory process, teachers can design more effective review strategies, such as using spaced review to help students better remember mathematical knowledge and solutions. Next, let's look at the object of our study. This part of content is from the 2nd semester of the 5th grade primary school curriculum in mainland China. At this time, the students have just learned the volume calculation of cubes and cuboid. For the object is not out of the knowledge of the regular objects for the time being. Measuring the volume of irregular objects is a good way to extend and apply the knowledge of volume. This is not only deepens the understanding of the concept of volume, but also teaches the application of theoretical knowledge to practical knowledge. Next, let's my group members introducing our teaching design.
The second part is the teaching design, and we design the instruction according to the 5E model. The first stage is the engage, and teacher by linking the period knowledge, asking how regular objects are calculated in volume, and then connecting the new knowledge, how to calculate the volume of irregular objects, and let students to think. And then by playing the video of Cao Chong with the elephant, inspire students and let students share their ideas. What have you gained? How do you think you can measure it? An initial perception of the meaning of transformation. And at the same time, playing videos stimulates students' interest in learning. The second stage is the explore. Students to think how to calculate the volume of an irregular object, and students may transfer irregular objects into regular objects for calculation, such as converting the plasticine to cube. But how to calculate irregular objects whose shape cannot be changed? Inspired by the story of Cao Chong with the elephant, using the drainage method, the volume of the rising part of the water is the volume of the object. But how to do it, how to measure it, and students are required to work in small groups for real and effective inquiry. And students work in groups for 4 to measure the volume of irregular objects using the experimental instruments such as the breakers and sinks. While completing the experiments, each group has a worksheet that students need to fill out and think about. What is your measurement process? What do you need to pay attention to while measuring? What data needs to be recorded? And what is the formula for measuring volume? And are there any different ways to measure it? The third stage is to explain. The teacher can invite students group to report and display the experiment result and the worksheet. And by reporting the experiment process and the method, the teacher emphasized that the measured object should be completely immersed in the water. And according to the report of each group, the formula for measuring the volume of irregular object is obtained. The volume of the irregular object is equal to the volume of water after rising minus the volume of water before rising. And after that, teachers can ask questions to students to think about. Can the volume of ping pong balls and ice cube can be measured by drainage method? The next stage is elaborate. Teachers present new scenarios and encourage students to apply what they have learned to the similar situations. For example, let objects into the breaker and some water overflows. How to calculate the object's volume. Guide students to derive formulas. The volume of irregular objects equal to the volume of rising water plus volume of spillage water. When the water in the breaker is full, then put the irregular object in. How to calculate the object's volume? Guide students to derive the formula. The volume of irregular objects equal to the volume of spillage water. The next stage is evaluate. After summarizing the knowledge of this lesson, give each student a worksheet of calculating the volume of the irregular object to evaluate their understanding. The difficulty of the worksheet problems range from simple to complex, from simple solutions of problems with formulas to a combination with problems with the weight. Partial immersion of objects instead of complete immersion. Encourage students to analyze and evaluate, and cultivate students' high-order skills. Finally, the teacher gives students a test to complete after class. Students complete the problem by analyzing the content of the picture. For normal level, students can get the volume of the big ball by guidance of 2 questions, and for the higher levels, students need to directly calculate the volume of the big ball.
In this part, we are going to analyze the lesson's instructional design in order to teach P5 students to know how to calculate the volume of irregular objects in 2 lessons. Here's the learning objectives. 1 is to learn to calculate the volume of irregular objects by the drainage method. 2 is the ability to choose appropriate solutions to different scenarios. There are 2 major components exist in this lesson design. One is 5-minute auto, the other is IPM. As shown in the test part of the figure, all steps of this process are designed to mobilize students' attention, using their senses to access new knowledge, thus activating interest in learning and more focused in the lesson process, building their personal understanding of the content of this lesson, thus understanding the application of the idea of transformation in life. And in the next stage, the teacher breaks down the knowledge into a step-by-step process, guiding students through a gradual exploration to discover the connection between calculating the volume of different shapes. Starting with calculating objects that can be transformed into regular shapes with their hands, and coming to problems that cannot be transformed into regular shapes. Students can easily relate to the use of the drainage method to calculate the volume of irregular objects, as derived from the video provided by the teacher in advance. And this process fully mobilizes the students' brain's ability to encode information and their attention. And through recollection and imagination and hands-on experiments, the absorbed information is filtered and reinforced, and then applied to real-world scenarios to solve problems. Students then follow the key prompts on the worksheet and recorded the data according to the group work, while receiving visual information to strengthen short-term memory to categorize the findings and summarizes the patterns, which transformed what they had learned into internalized long-term memory. And then, in the explain stage, pupils can practice expressive skills by sharing to persuade others to accept their methods of measuring irregular objects. And teacher promotes a variety of forms of presenting results, such as worksheets. This approach deepens students' understanding and subsequent reflection and evaluation of information provided by others, and also provides opportunities for students to identify and correct errors. Then new challenges emerge, thus making students thinking outside the box to make the solution, which requires students to use higher order thinking skills. And now is about elaborate. Students are given additional activities and tasks to deepen their understanding and apply their knowledge in new contexts. It is through the teacher to provide a hierarchy of questions. Students can gradually deepen the ability to analyze, so as to master the actual situation, should choose how to solve the problem of skills, and through repeated practice to strengthen deepened application of knowledge, so that students can sum up the pattern of questions to draw the law, therefore develop their mathematical thinking skills, reasoning senses, and so on. Finally, it is the evaluation step. In this section, the instructional design is to test students' knowledge with 2 questions at different levels of proficiency. This allows the teacher to identify any areas for improvement and provide feedback to students. And this lesson design is based on the activity, and it is student-centered, so that students in the operation, experiment, comparison, cooperation, and exchange of activities, independent design of the activity program, exchange of activity experience, summarize the results of the activities to achieve the change from passive listening mathematics to active doing mathematics, and effectively improve the learning style of students. The change from passive listening mathematics to active doing mathematics has been achieved, which effectively improves students' learning style and increases the efficiency of classroom teaching. At the same time, it also enables students to participate in the process of learning and exploring activities, constantly experience the pleasure of success and stimulates students' interest in learning mathematics.
The last part is our conclusion. The whole lesson design is based on constructivism, 5E model, and IPM. Like we illustrated before, for constructivism in our lesson design, teacher-students talk and group discussion can provide social interaction. Students can understand how to calculate the volume of irregular object through hands-on activity and group discussion in Explore session. And the differentiated exercise for evaluation, homework, and tasks can support individual development of learners. As for IPM, the learning activities we design in the process of engage, explore, and explain are referring to create student sensory memory. In terms of sensory memory, basically there are three senses involved. They are sight, touch, and hearing. First of all, the video, activities, and worksheet can mobilize students' vision. Then, hands-on activity in Explore session can induce students' sense of touch. In addition, students can always hear from teachers' talk, group members' ideas during discussion, and the other classmates' sharing. After students generate their sensory memory, we need to help them convert sensory memory into short-term memory. There are several approaches that will be useful. For example, attracting students' attention, providing students with chances to organize, and then to repeat their received message. So what do we do in our lesson design? Firstly, the video at the beginning and the question posed by teacher can arouse students' attention. Then hands-on activity as well as group discussion in Explore session can offer students chances to have an organization on what they have perceived. What's more, students can have a reputation by working on the worksheet and sharing his or her ideas to others. After students store their short-term memory, we often support in turning short-term memory into long-term memory. Here are our strategies to help students encode their short-term memory. Firstly, we inspire students to think about the situation that the water might overflow. Through the elaboration of this question, students can further identify the numeric pattern and the relationship between the volume of irregular objects and the water. Because this kind of situation would occur in our daily life, students can apply their knowledge to the real world. Also, exercise would allow students to have an evaluation on what they have learned. Besides, the exercise is designed in differentiation to provide scaffolding to different level students. Last but not least, we all know that even long-term memory can be forgotten. However, some measures such as homework and tasks can help students change this dilemma and retrieve from their long-term memory, then consolidate their knowledge. Thus, although it is the last step of lesson design, homework and tests are also important. In conclusion, when we design the lesson, constructivism suggests that students' prior knowledge and experience have an important influence on their learning process, and knowledge is actively constructed by the learner rather than passively received. Besides, 5E model provides us with a clear structure so that we can check if there is any missing from our initial proposal. Then we can have an overall improvement of our teaching design. Furthermore, IPM can let us have a chance to consider how children's ability to meet the processing demands of a particular task changes over time, and how to lead students to achieve a high degree of precision in describing cognition. Here are our references. And that's all for our sharing. Thank you for your time.